Hi everybody, and welcome to topic number 13, factoring by GCF and grouping. In this video, we're going to take you through two objectives. We're going to show you how to factor a greatest common factor out of a polynomial with any terms, as well as factoring by grouping a polynomial that has four terms. What is factoring? Factoring is the reverse process of multiplying. It is the process of writing a polynomial as a product. So when we did polynomial multiplication, for example, we FOILed the answer out. Now we're going to unfoil the answer and get it back to its original state. You'll see the flow chart here to kind of help us remember all the factoring techniques we're going to see over the next couple of videos. Today we're going to focus on two of them. We're going to focus on the greatest common factor, which we can use for a polynomial of any size, and we're also going to focus on factoring by grouping, which will include polynomials that have four terms. In subsequent videos, we will take care of the ones that have 3 and 2 terms. The greatest common factor, or GCF, is the largest factor of each term has in a common. They can include both numbers and variables. The GCF can be found in a polynomial of any term length. So that means whether the polynomial has 2, 3, 4, or 10 terms, we can always look for a GCF. That's not the case with all the other types of factoring. GCF is the only one where it does not matter how many terms are in the polynomial. In terms of numbers, the largest number all numbers have in common is the greatest common factor. So when I look here, I have 40, 30, and 65. I have to find the biggest number that can go into all three of these. One skill that we like to do is we like to take the smallest number and find its factors and see what one is the biggest that goes into all three. So when I look at 30, I know, for example, that's 1 times 30, or 2 times 15, or 3 times 10, or 5 times 6. So these will be my potential items, and I'll start from the biggest number, and I'll go to the smallest. So when I look at 30, I know 30 is going to go into 30, but 30 will not go into 40, so we'll get rid of that. 15 will not go into 40 as well, evenly. Now 10 will go into 40 4 times, and we already know 10 goes into 30, but 10 does not go into 65 evenly. If you did that on a calculator, you would get a decimal. So 10 is not our GCF. 6 does not go into 40, so we'll get rid of that. But when I look at 5, 5 goes into 40 8 times, 5 goes into 30 6 times, and 5 goes into 65 13 times. So 5 would be the greatest common factor in this case. We'll take a look down here. Same thing. We'll always look at the smallest number to help us find the GCF. 8. I've got 1 and 8, 2 and 4. Yes, 8 goes into 72 and 8, but it does not go into 15. 4 as well goes into both of those. 4 does not go into 15. 2 does not go into 15 as well. So at this point, when you're left with 1, that has to be your GCF, which basically means that none of the numbers have anything in common. In terms of variables, the largest exponent each variable has in common is the greatest common factor. So one of the things you need to do is make sure do all the terms have that same variable, and if you do, how many is the most that you can take out without running out. So for example, when I have x4, x9, and x3, they all have x's. The most amount of x's I can take out is 3. Once I take out 3, this last term doesn't have any more I can take out. So the GCF here would be x cubed. For the y's, I have y5, y to the first power, because remember, if there's no exponent, it's really to the first power, and y to the 8th. Well, I can only take out one y in this case. When I have multiple variables, we have to check do each of the variables exist in each of the terms. So when I look here, I've got a's in all 3 terms, so I know I'm going to have an a that could factor out. I have a3, a4, and a6. 3 is the smallest one there, so I will use that as my GCF. All the terms have b's in it. I've got b2, b1, and b7. 1b is the smallest. So my GCF here will be a cubed b. Now this last set, I've got 3 letters, and we'll double check. All the terms have x's, x2, x4, x5. So I can take out an x squared. Let's look at the y's. I've got a y3, a y3, and a y1. Again, all the terms have y's. So let's take out a y. But if you notice in the last one for z, I only have a z here, and I only have a z here. This middle term does not have any z's. So that means there cannot be any z's included in my GCF. My GCF would simply be x squared y. So again, I didn't use z, so no z, because second term had none. If not all the letters are in there, you cannot take it out as a greatest common factor. So what we're going to do is we're going to factor out the greatest common factor from each of these polynomials, and then once we find the greatest common factor, we're going to divide each of the polynomials by that to get what remains. So for example, here we've got 15a and 25b. We're going to take a look at the numbers and the letters separately. So 15 and 25. Again, we can look at 15 and look at its multiples. And we're trying to find the biggest number that can go into 15 and 25 evenly. We know 15 doesn't work, but 5 does. So we can have a GCF of 5. And I notice my variables are different, so I'm not going to have any variables that are the same. So 5 is my GCF. We're going to divide everything here by 5 to get the inside. 15 divided by 5 is 3. The a comes down with it. 25 divided by 5 is 5. And the b comes down with it. So this would be my factored out polynomial. Let's do the same for the next one. We've got 14 and 35. So we look at 14. That's 1 and 14, 2 and 7. 14 does not go into 35 evenly, but 7 does. So we can factor out a 7. And I have both of these terms having u's, so I have to pick out the smaller of the exponents. Well, that would be u2 here. So my GCF would be 7u2. I'm going to divide both terms by 7u2. I'm going to divide the numbers, and I'm going to subtract the exponents. 14 divided by 7 is 2. u2 divided by u2 is 2 minus 2, which is 0. So those cancel. 35 divided by 7 gives me 5. u4 divided by u2. Again, that's the same as really doing u4 minus 2, which would give me u squared. So this would be my factored out answer. Again, we'll do the same with 3 terms here. We have 7, 28, and 35. 7 only has 1 and 7 as factors. 7 does go into 28 and 35, so we can use 7 here. We see all 3 terms have c's. This one has 3 c's, 2 c's, and 1 c, so the most I could take out is 1 c. And these back 2 terms have d's, but the first term doesn't have any d's with it, so we cannot go through and take out any d's. Our GCF is simply 7c. So I'll take all the terms and divide them by 7c. 7 divided by 7 is 1. c3 minus c1 is c squared. Negative 28 divided by 7 is negative 4. I have 2 c's. I take away 1. I've got 1 c left. The d I didn't do anything with, so it comes down. 35 divided by 7 is 5. I have 1 c. I take it away. I don't have any c's left. And I do nothing with the d's. It comes down as part of the answer. Let's try it one more time with the last term. I got 13, 39, and 26. 13 can go into both of those, so we'll take out a 13. Each term has a's. The smallest a I have here is 13a. Each term has a b. Again, the smallest one I have here is a b. So we're going to take everything here and divide it by 13ab. Again, we divide the numbers and we subtract the exponents. 13 divided by 13 is 1, and you don't have to put the 1 here unless there's no other, unless the variables all cancel, but since the variables aren't going to cancel, we don't have to put the 1. a3 minus a1 is a2. b2 minus b1 is just b. 39 divided by 13 is 3. a2 minus a1 is a. b1 minus the b, those b's cancel. Negative 26 divided by 13 is negative 2. I have 1a and I took it away. I have 4 b's, I take away 1b, and I have 3 b's left. So this would be my final answer. Two more problems to look at here. Again, we're going to look at what is the biggest number I can take out of 24, 8, and 4. I see a 4 here. 4 can go into both 8 and 24. So we're going to take out a 4. Each of the terms have an x. I'm going to take out an x3 because that is the smallest x I have here. And each of the terms have a y. So I'm going to take out a y. So I'm going to divide everything by 4 x cubed and y. Again, divide the numbers and subtract the exponents. 24 divided by 4 is 6. 5 minus 3 gives me x squared. y3 minus y1 is y squared. Negative 8 divided by 4 is negative 2. x4 minus x3 is just x1. y2 minus y1 is y. Now, interesting here, if you look, I have the exact same thing on the top and the bottom. The 4's are going to cancel, the x3 is going to cancel, and the y is going to cancel. So think back to division. When something divides by itself, it becomes 1, and that's what's going to happen here. We're going to have to put a negative 1 as our placeholder. It's negative because of the minus sign, and everything canceled, so we have 1. So if you kind of want to think about it, this is our answer. And the 1 makes sense because if I went back and distributed and I did 4x cubed y times negative 1, I would get back this term here. So if everything cancels, make sure you put a 1 down there for your answer. Now this last one is interesting because it starts with a negative. And the rule is if it starts negative, then the GCF must be negative. So we're going to do the exact same thing. But whatever number we take out, we're going to do it as a negative. When I look at 25, 25 can go into 150. So generally we would factor out a 25, but now we're just going to factor it out as a negative 25. Each term has an x. I can take out 1x from the last one. Each term has y's. I can only take out 1 y from the last one. So we're going to divide everything by negative 25 xy. We'll divide all the numbers. And we'll take away 1x and 1y from everything. Negative 25 divided by negative 25 is 1. 8x's take away 1x is x to the 7th. y5 minus y1 is y to the 4th. 100 divided by negative 25 is negative 4. 4x's I take away 1, that's x3. y4 take away 1y, that's y3. Negative 50 divided by negative 25 is positive 2. Here the x's cancel and the y's cancel, so that's all I have left. So make sure if your first term starts negative, then your GCF has to be negative as well. Factoring by grouping. Factoring by grouping is used when there is 4 terms in the polynomial. So to make that distinction here, we can only use factoring by grouping if there are 4 terms. That is the only time we can use factoring by groupings. And essentially what we're going to do is we're going to group the first 2 terms and factor out the GCF, and then we're going to do the same for the last 2 terms and factor out the GCF. If we do that, we should have a common GCF in common, and then we'll go through and write our answer. So factoring by grouping is really just doing 2 GCFs within the groups of 4 that we have. Let's show you some examples. So here we've got a 4-term polynomial. Again, remember terms are separated by plus and minus signs. So 3x squared is the first term, 9x is the second term, 4x is the third term, and 12 is the last term. And what we're going to do is we're going to split these into 2 sets of 2. And we're simply going to take the GCF from each of them. So 3x squared and 9x, I could take out a 3, that is the biggest one, and I could take out 1x. So I'm going to have a 3x when I take that out, and I'm going to divide both terms by 3x. 3 divided by 3 is 1, x squared, take away an x, just leaves me with x. 9 divided by 3 is 3, and here the x's cancel, so that leaves me with x plus 3. Let's do the exact same thing for the second term, 4x and 12. I'm going to look for the GCF. 4 and 12, I can take out a 4. That's the biggest number that I've got. And this one has an x and this one doesn't, so I can't take out anything else with it. So 4 is the GCF of this. So I'm going to divide each of these terms by 4. 4x divided by 4, the 4's cancel and it just leaves me with x. 12 divided by 4 is 3. Now if you notice, after I took out the GCFs, what happened to the two parentheses that were left? They came out to be exactly the same. And if you did your grouping correctly, this should happen every time. Your parentheses should be exactly the same. To write our answer, we're simply going to take what we did as our GCFs and put them in one parenthesis, and then one of the same will be in the other. So for my final answer, I'll have 3x plus 4 in one parenthesis. Then the other parenthesis will be my x plus 3. So you can think of that as like reverse FOILing. Let's do the same for the second problem. We're going to group it off into two sets of 2, and our job is to find the GCF. 2x squared and 5x. Well, 2 and 5, 2 can't go into 5, so that means I don't have any number that I can take out of 2 and 5. But they each have an x, so I could take out an x from each of the first two terms. When I do that, 2x squared, you take away 1x, I just have 2x. 5x, you take away the x, I just have a 5. Now for the second term, again, remember, it starts with a negative. So if it starts negative, that means you have to factor negative. Negative 2x plus 5. Well, again, 2 and 5 don't have anything in common. And this one has an x and this one doesn't have anything. So there's nothing that they have in common here. So when you don't have anything in common, that's like factoring out a 1. But because this starts with a negative, we'll have to factor out a negative 1. And I think that'll make sense when you see the division. If I do negative 2x divided by negative 1, negative divided by negative becomes a positive 2x. 5 divided by negative 1 becomes negative 5. And now I know it worked because if you look at my parentheses, they turned out exactly the same. So my final answer here would simply be x minus 1 from the two things that I factored out, 2x minus 5. I also want to note, if you wrote the 2x minus 5 first and the x minus 1 second, that is okay as well. It does not matter the order that you write the terms, as long as you group them and factor them out correctly. Let's do it again with this problem. We'll factor the first two terms. 5x squared and 30x, 5 and 30, you can take out a 5. X squared and x, I can take out 1x. So dividing everything by 5x. 5 divided by 5 cancels. 2 x's, I take away 1x, I've got an x. Negative 30 divided by 5 is negative 6. Here the x's cancel. From the second group, 2 and 12, I can factor out a 2. This one has an x, this one doesn't, so all I can take out is a 2. 2x divided by 2 just leaves me with x. Negative 12 divided by 2 leaves me with negative 6. Again, I knew I did a great job because these came out to be exactly the same. So my answer here, take the two outsides, 5x plus 2, and one of the same, 2x minus 6. And that would be my final answer. One more time over here. 3x squared and 18x. 3 can go into 18, so let's take out a 3. X squared and x, I can take out 1x. 3x squared divided by 3x just leaves me with x. 18x divided by 3x, 18 divided by 3 is 6. The x's cancel. Now again, second term starts with a negative, so we're going to factor out a negative when we do this. 7 and 42, I can take out a 7. We just have to make it a negative 7. This has an x, this does not, so 7 is the most that I can factor out here. Negative 7 divided by negative 7 is positive 1, so this is just 1x, or x. Negative 42 divided by negative 7 is positive 6. Again, we're looking to see those parentheses be the same. My final answer should be 3x minus 7 and x plus 6. So really grouping is just doing two different GCFs and finding what they have in common. Let's show you a couple more to wrap up the video. Again, let's take 5x squared and 40x, negative x minus 8. 5 and 40, they have 5 in common. They also have an x here. Divide everything out by 5x. 5's cancel out. X squared divided by x is x. 40 divided by 5 is 8. And here the x's cancel. Again, we start with a negative term, so we got to factor it out as a negative. X and 8, I've got one variable and one number. Nothing's going to factor out, so we have to put a 1 there. Dividing everything by negative 1 just flips the signs. Negative x divided by negative 1 is positive x. Negative 8 divided by negative 1 is positive 8. These two are the same again. So my final answer, 5x minus 1, x plus 8. Let's take a look here at these two problems. 5x squared minus 40x. Again, we can take out a 5 and an x. 5x squared divided by 5x is x. 40x divided by 5x just leaves me with the negative 8. 3x plus 24. I take out a 3. And when I do that, I'm left with an x plus 8. So now we get to a point where we see these aren't the same. So that is incorrect. So we need to figure out if this can actually factor, or do we have something that's unfactorable. The other way that we can try it is we can flip the middle two terms to see. So I could take this as 5x squared plus 3x minus 40x plus 24, and we could see if these come out any better. So if I do it this way, 5x squared and 3x, the only thing I can take out is an x. Well, that will leave me with 5x plus 3. Negative 40 and 24. Again, we have to factor it out as a negative. 40 and 24. So let's look at 24. We've got 1 and 24, 2 and 12, 3 and 8, 4 and 6. Trying to see what can go into 40. 24 can't, 12 can't, but 8 can. So let's factor out a negative 8. Negative 40 divided by negative 8 is positive 5x. 24 divided by 8 is negative 3. So we go through. These are not the same. So what does that mean when they come out to be not the same in this case? Well, that means there is no solution. There is no way to go through and factor this problem. Let's take a look at things with multiple variables. We're going to do the exact same thing. We'll just have to be careful with the variables. There's no numbers here, so we can't take out any numbers. I can take out one m from this, and I can't take out any n's because only this last term has an n. So we take out one m from everything. So that becomes an m, and this m goes away, and all I have is 8n. Again, this is negative, so we have to factor out a negative. 3 can go into 24, so let's factor out a 3. I can't take out any m's, but I could take out one n because both these terms have n's, and this one has 1. So I'm dividing everything by negative 3n. So here the 3's cancel and the n's cancel. It just leaves you with m. Negative 24 divided by negative 3 is positive 8. 2 n's minus 1 gives me 1n. We're back to how we want it. We have them exactly the same. My answer should be m minus 3n and m plus 8n. One last time. So again, we're looking at multiple variables here, so we got to see and make sure does everything have it. 6x squared and 2xy squared. So 6 and 2, the biggest number we can take it as 2. Both the terms have x's. I only have one x here, so I'll take out an x. Both the terms have y's, so I'll take out one y from each. So dividing everything by 2, xy. 6 divided by 2 is 3. X squared, take away 1x is x. Here the y's cancel. 2 divided by 2 is 1. Here the x's cancel. Y squared divided by y is 1y. Looking at the last group, negative 27 and negative 9. Again, it starts with a negative, so factor out the negative. 9 goes into 27, so we can take out a 9. We only have an x in this term and a y in this term, so no variables can be factored out here. So we're just going to divide everything by negative 9. Negative 27 divided by negative 9 is 3. The x comes down with it. Negative 9 divided by negative 9 is positive 1 with the y. So again, like we've shown you, these should come out to be the same if it's correct. So my answer here is 2xy minus 9, 3x plus 1y. Again, I want to stress you can only do grouping if you have a polynomial with 4 terms. So if you see a polynomial with 4 terms, one of the things that you should look to do is see, can you factor by grouping?